Hey fellow SOS cadets! Today we're diving into the most mind-blowing phenomena in the universe. Explosions so massive they make the biggest bombs on Earth look like mere firecrackers. Imagine fireworks but on a cosmic scale where the energy released is beyond comprehension. What if I told you the biggest explosions in space make every bomb on Earth look tiny, like a little sparkler? These cosmic events are not just spectacular, they are fundamental to the universe's evolution. They create and destroy, shaping galaxies and even influencing the formation of new stars and planets. These explosions in space are so powerful, they release more energy in seconds than our sun will in its whole life. Supernovae, for instance, are the explosive deaths of massive stars, releasing a burst of energy that can outshine entire galaxies. The sheer scale of these events is almost impossible to fathom. Way out there, stars are dying, black holes are crashing into each other, and galaxies are being ripped apart. These cataclysmic events are not just random occurrences. They are part of the cosmic dance that has been going on for billions of years. Each explosion, each collision plays a role in the grand tapestry of the universe. Come with me as we explore the most powerful explosions the universe has to offer. We'll journey through time and space, witnessing events that have shaped the cosmos. From the explosive birth of stars to the violent collisions of black holes, we'll uncover the secrets of these awe-inspiring phenomena. We'll look at exploding stars, crashing black holes, and everything in between. These events are not just spectacular to watch, they are crucial to understanding the universe. So buckle up, because this journey through the cosmos is going to be explosive. Let's talk about dying stars. These celestial giants have fascinating and dramatic ends that shape the universe in profound ways. When a giant star, way bigger than our sun, runs out of fuel, it explodes. These stars, often many times the mass of our sun, undergo a series of complex nuclear reactions in their cores, fusing elements heavier and heavier until they reach iron. Iron, unlike lighter elements, doesn't produce energy when it fuses, so when a star's core is filled with iron, it can no longer sustain the nuclear reactions that keep it from collapsing under its own gravity. This explosion is called a supernova. Supernovae are among the most energetic events in the universe, releasing more energy in a few seconds than our sun will emit in its entire lifetime. The light from a supernova can outshine an entire galaxy for a short period. The star's center gets crushed by its own weight. As the core collapses, it reaches incredibly high densities and temperatures, causing the outer layers of the star to be ejected violently into space. This happens so fast that it gets super hot and creates a huge shockwave. The shockwave travels outward, heating and compressing the surrounding material, which can trigger the formation of new stars in nearby clouds of gas and dust. The shockwave blasts the star apart, sending stuff flying across space. This material, rich in heavy elements, spreads out and mixes with the interstellar medium, seeding future generations of stars and planets with the building blocks of life. But this isn't just destruction, it's a cosmic recycling process. The elements created in the heart of the star are now free to form new celestial bodies. This explosion creates new stuff, like gold, silver, and even uranium. These elements are forged in the intense heat and pressure of the supernova explosion, and they are essential for the formation of planets and life as we know it. This stuff spreads out and eventually makes new stars, planets, and even life. The remnants of the supernova mix with other material in space, and over time, gravity pulls this material together to form new stars and planetary systems. We are made of star stuff. The elements that make up our bodies were formed in the cores of stars and scattered across the universe by supernovae. Some supernovae happen when a small star steals fuel from a bigger star. In binary star systems, a white dwarf can pull material from its companion star, leading to a runaway fusion reaction that results in a Type Ia supernova. Others happen when really big stars collapse and create black holes, or neutron stars, which are super heavy. These remnants are incredibly dense. A neutron star, for example, packs more mass than the Sun into a sphere just a few kilometers across. The Crab Nebula, a beautiful cloud of gas in space, is what's left of a supernova from the year 1054. This supernova was so bright that it was visible in daylight for weeks. Supernovae can even affect Earth. The radiation from a nearby supernova could potentially strip away our planet's ozone layer, exposing life to harmful ultraviolet radiation from the sun. Studying them helps us understand how stars live and die and how the universe changes. By observing supernova, astronomers can learn about the life cycles of stars, the formation of elements, and the dynamics of galaxies. If supernovae are big explosions, then gamma-ray bursts are the biggest fireworks in the universe. These cosmic events are so powerful that they can outshine entire galaxies for a few seconds. Imagine the energy of a supernova, but concentrated into a narrow beam that can travel across the universe. That's what makes gamma-ray bursts so fascinating and terrifying at the same time. These are short bursts of powerful energy called gamma rays. Gamma rays are the most energetic form of light, and they can pack a punch that is hard to imagine. When these bursts occur, they release more energy in a few seconds than our sun will in its entire 10 billion year lifetime. Imagine a beam of energy so strong it's brighter than an entire galaxy. That's a gamma ray burst. These bursts are so intense that they can be detected from billions of light years away. They are like cosmic lighthouses, sending out beams of energy that can be seen across the universe. The sheer brightness and energy of these bursts make them one of the most extreme phenomena in the cosmos. We're still figuring out what causes all of them, but we know they happen when big stars die or when neutron stars crash. When a massive star runs out of fuel, it can collapse under its own gravity, leading to a supernova explosion. In some cases, this collapse can also produce a gamma-ray burst. Similarly, when two neutron stars collide, the resulting explosion can also generate a gamma-ray burst. These events are incredibly rare, but when they do happen, they release an unimaginable amount of energy. These explosions send out beams of energy at almost the speed of light. The beams are so powerful that they can travel across the universe without losing much of their energy. This means that even gamma-ray bursts that occur billions of light years away can still be detected by our instruments here on Earth. The speed and energy of these bursts make them one of the most fascinating subjects of study in astrophysics. If one of these beams hit Earth, even from far away, it could be really bad. The energy from a gamma-ray burst could strip away the ozone layer, which protects us from harmful ultraviolet radiation from the sun. Without the ozone layer, life on Earth would be exposed to dangerous levels of radiation, leading to severe consequences for all living organisms. It could damage our atmosphere. The loss of the ozone layer would not only increase the risk of skin cancer and other health issues for humans, but also disrupt ecosystems and food chains. The impact on the atmosphere would be devastating, leading to long-term changes in climate and weather patterns. Gamma-ray bursts show us the most extreme parts of the universe. They are a reminder of the incredible forces at work in the cosmos and the delicate balance that allows life to exist on Earth. By studying these bursts, we can learn more about the life cycles of stars, the nature of black holes, and the fundamental laws of physics that govern the universe. Studying them helps us understand gravity and what happens to stuff when it gets squeezed really hard. Gamma-ray bursts provide a unique opportunity to study the most extreme conditions in the universe. By observing these bursts, scientists can test theories of gravity, learn about the behavior of matter under extreme pressure, and gain insights into the processes that drive the evolution of galaxies and the universe as a whole. Black holes are places where gravity is so strong that nothing, not even light, can escape. Imagine two black holes crashing into each other. This collision is so powerful it creates ripples in space itself, called gravitational waves. Einstein predicted these waves a long time ago. These waves are like ripples in a pond when you throw a rock in. They travel across the universe at the speed of light. In 2015, scientists actually detected these waves. This was a huge discovery. Now we can hear the universe by listening to these waves. At the center of many galaxies are supermassive black holes, much bigger than our sun. When stuff falls into these black holes, it gets super hot and creates a bright light. These bright centers of galaxies are called quasars. Quasars are so bright, they outshine entire galaxies. They're like giant cosmic light bulbs. By studying quasars, we can learn about how galaxies form and how black holes grow. Now, let's talk about the biggest explosion of all, the Big Bang. It wasn't like a regular explosion, it was more like everything suddenly expanding. Space and time began, and everything started moving outwards. Imagine everything squeezed into a tiny point, and then suddenly it started expanding. That's the Big Bang. The universe is still expanding today. The Big Bang created everything, hydrogen, helium, and all the other stuff that makes up stars and planets. The universe is a wild and amazing place, full of explosions. But the more we learn about these explosions, the more we understand our place in the universe. Thank you for exploring with me. Subscribe for more space videos and tell me in the comments what your favorite cosmic explosion is.